to Timberwolf Tutoring. Today we are covering an integrated math 2 topic, particularly special right triangles. So you may be asking yourself, what are special right triangles? And here we are. There are two types of special right triangles. We have 30, 60, and 90, which is the angles that it has. So there's 30, and then there's 60, and then there's 90 for the angles. And then there's a 45, 45, 90, or basically an isosceles triangle, where you have a 45-degree angle, 45-degree angle, and a 90-degree angle. And so really the big thing with these is that we're going to want to understand mathematically how they're all connected. And with this formula for the special right triangles, they're always going to have these same results. And so we can see that with the 30, 60, 90 because we have this variable. I myself am using n because of the fact that x and y are going to come up later in practice problems. And so to avoid confusion, I'm not going to make it x like any other variable. But with that, we have, with the 30, 60, 90, we have n times the square root of 3, and 2n. For the 45, 45, 90, we have n, and n times the square root of 2. It makes sense that we have two n's for this because of the fact that it is, of course, an isosceles triangle. So what kind of rules are you going to need to know about this specifically? And here we have them, the rules themselves. So if you remember trigonometry, you know that we had to go across an angle to a side many different times. That's finding the opposite side, of course. Well, you're going to want to do something sort of like that in this case, because what you do to figure out which one is which, if you're looking, let's say you get a triangle with just the angles and you don't know which number or quantity rather is which. So what you can do is across from 90, the 90-degree angle, is always going to be 2 times n. Across from the 60-degree angle is going to be n times the square root of 3. And for the angle 30, always across from it is going to be n. And the same applies for 45, 45, 90, where if it's across from 45, it's going to be n, and if it's across from the 90, it's going to be n times the square root of 2. And as a small little trick, what you can do is let's say that in a problem you're given this as a whole number. Let's say 8, for instance. Let's say that you just get this number as 8 and nothing else. Well, a trick you can do to simply find it is to divide that number you get by 2 and then multiply it by the square root of 2. So that would come out to, if it's 8 divided by 2 equals 4 times the square root of 2, that would be 4 times the square root of 2. And so how we're going to find the values for this is an example of a 30, 60, 90. And just looking at this, we're going to want to figure out what each of the values are. So if we look here, we know that 12 is equal to n times the square root of 3. So everything else has to be based on that. So we have that right here, right? And you might be wondering, how are we going to be able to isolate the variable, the n in this case? Well, what we're going to want to do is, if you're trying to get a multiplied factor away from a variable, you have to divide it, because that's essentially canceling it out. So you divide each side by the square root of 3, and you get 12 times the square root of 3, and then you get, which equals n times the square root of 3 divided by the square root of 3, which comes out to 12 divided by the square root of 3 equaling n. Now, as determined by the laws of math, we are not able to have a square root as our denominator. So the way that we get around that is we cross multiply each side by the square root of 3. And so what that's going to look like is we have the square root of 3 divided by the square root of 3 times 12 over the square root of 3. And if you do not remember to cross multiply, it's just like it sounds. You take this and multiply it to that, and you take that and multiply it to that. And that leaves you with 12 times the square root of 3 divided by the square root of 9. And we can simplify this a little bit. So what we can do is we then simplify it, and if you look, that's going to come out to 12 times the square root of 3 divided by 3. And we can even simplify that a little more. We can divide this, because it is divisible by 3 after all, 12 divided by 3. You get 4 times the square root of 3, and that's what we get for our variable. And so we then apply the variable, the n value, as you see fit in the problem. So you could plug it into 2n, you can plug it into whatever you need to, just to get those results. And so that's going to look like is 4 times the square root of 3, and then 2n would be 8 times the square root of 3. And so what I'd like for you to do now is I have a set of practice problems here, and these cover both the 45, 45, 90 and the 30, 60, 90. And upon completing these, the answers for these are going to be available in the description of the video itself. Thank you, and have a great day.